Alex, Michael, Jennifer, how are you?
Good. How are you doing today, Danny?
Good, good, good. I think we're about ready to get going. Does that sound good to everyone?
Perfect.
Sounds good.
Awesome. Awesome. Okay. Welcome everyone to Unilock's 2022 UTech Virtual Specifier Education Series. My name is Danny Gatto and I will be today's host and moderator. Thank you for taking time out of your day and joining us. We'll begin with a quick introduction video presented by David Laurie from Unilock.
Hello, my name is Dave Laurie, Sales Manager, Commercial Sales, Unilock Canada. I began at Unilock in 1997 during Unilock's 25th year in business. This year, Unilock is celebrating its 50th year in business. Unilock began with one paver named Unistone, available in a single color. We now have a 170-page catalog featuring a large variety of products. When I began at Unilock, I was one of 5 sales reps in Canada. We now have 18 sales reps, including our newly added Quebec business operation. Our sales have grown significantly, and the size and number of production plants have also increased, both here in Canada as well in the US, centered around the Great Lakes. Unilock began with commercial projects in 1972 with the Unistone, then grew tremendously in the residential marketplace, becoming a significantly well-marketed household product name for many years. Approximately 20 years ago, Unilock began to renew our focus on the commercial world of spec build projects. Sales rep like myself in Ontario, as well in New York and Chicago, moved from an all-round sales rep role looking after both residential and commercial business to a focus on commercial work only. With a high level of focus on commercial work, the emphasis was on getting Unilock specified by architects, landscape architects, and engineers. This led to a significant focus on doing lunch and learn presentations to this audience, working hard to become the most sought after company for commercial projects, product supply for pavements and retaining walls. Like the lunch and learns that Unilock sales reps have presented for many years now, the company's long-term objective is to provide the most current information to ensure all the best practices are being followed in both the design and construction of the systems that Unilock products are used within. Unilock understands that not only do our products need to be of the highest quality, but the partnership between our firm and yours in working towards high quality installations is of the utmost importance. We are proud to bring to all of you our 2022 UTech Virtual Specifier Education Series. Thank you.
That's great. Thanks, Dave. Appreciate the video. Again, thanks everyone for joining us today. A few housekeeping items I will go over. The questions can be taken using the question and answer function. It should be on the right side of your screen. I did put in a comment there. Hopefully everyone can see it and can use it. I see someone has already entered some text there, so we'll definitely moderate that. Also, we will have a few quick question breaks within Alex's recorded segments, followed by our guest speakers live segment. So part 1 of our education series is Permeable Pavements with PICP, Design and Construction Best Practices. Of course, OAA and OALA Con Ed learning hours are available for members. PEO Con Ed learning hours are also available for members. A letter can be provided from Unilock to each attendee confirming their attendance at the seminar. We'll also be posting a link to a quick survey. The survey will also be emailed to you, but we will definitely provide that link in the question and answer box. So I'm going to begin with a brief history of Unilock, followed by the recorded segments with Alex. Unilock was founded by Ed Bryant 50 years ago, and the Bryant family are still the decision makers today. They continue to guide the company and make Unilock successful. 2022 marks a huge milestone for Unilock. It's our 50th anniversary. Unilock was the first manufacturer of concrete unit paving in North America. We are a Canadian company with our first operation beginning in Barrie and have since expanded our operations to Ayr, Gormley, Pickering, and Georgetown locally. We also have US locations in Boston, Chicago, Cleveland, Detroit, Milwaukee, and New York, and we're growing. We source local materials to manufacture our products, helping the communities that we operate in. We manufacture quality products by producing unit paving and wall blocks with precise dimensional tolerances, low absorption rates, and high compressive strength. All of our products meet but more often exceed industry standards. Unilock is a trendsetter and drives the unit paving and retaining wall industry with new and innovative products. We have a large number of commercial team professionals across all of our Unilock locations in Canada and the US, ready to assist you. In addition to our commercial team, we have over 65 territory managers servicing our contractor and dealer network in your area. Locally, we have a dedicated commercial sales team servicing the design community, engineers, and commercial contractors with a great focus in the Greater Toronto area, along with 4 territory managers looking after the outlying areas of Southern Ontario, from the Golden Horseshoe to the Ottawa region and north to Georgian Bay region. We also have 3 project administrators to support our Unilock commercial team. As mentioned, Unilock has over 18 manufacturing facilities and counting, spread across 13 locations in Canada and the US. Here is our seminar outline for today. We'll start with an introduction to permeable pavers presented by Alex Bartolo. We will then take a quick break for question, followed by our guest speaker, Jennifer Drake from the University of Toronto. We'll then wrap up our seminar with a question and answer session. Of course, we'd love to hear from you, whether it's to review our product specifications, industry standards, or if you're currently working on any projects, we can definitely assist you. Please contact Alex or myself with any questions you may have. Here's our contact info. With that said, we'll begin with the recorded segments from Alex. Alex has been with Unilock for 4 years. He has a bachelor's degree in urban planning and a master's in landscape architecture. He is also a licensed landscape architect and a certified technical representative with Construction Specifications Canada. I will now pass it over to Alex to begin with the recorded segments.
Welcome to the presentation on permeable pavements. My name is Alex Bartolo, and I will be taking you through the presentation today. Here's the agenda for today's presentation. We will begin with an introduction, followed by 2 case studies, manufacturing standards, benefits of permeable paving, design considerations, maintenance, and lastly, product information. Section 1, Introduction, a brief overview on permeable unit paving. This is a typical permeable paving detail, and it is important to note that the depth of the base material varies depending on site conditions. Different infiltration rates due to site soils and the loading the pavement will receive are 2 factors that strongly relate to the depth of the granular base. Starting from the bottom up, you have the native or emitted site soils followed by a geotextile layer that is intended to stop the proposed base aggregates from migrating into the native or emitted site soils. Following the geotextile layer is the subbase material, which is a larger aggregate with a 40% void ratio for the purpose of structural stability and infiltration of water. This subbase aggregate can pool water and work similar to a storage tank while the water infiltrates into the site soils if necessary. The next layer is the base material that consists of a smaller washed aggregate for low dispersion and permeability. Above the base material is the bedding material, which is yet another smaller aggregate material that helps set the unit paving. It is also permeable. The top layer is the unit paver and the joint material that consists of the same material as the bedding layer. All of these layers, when combined, form a strong system where the aggregates will not migrate between each layer due to their specific size and shape. Later in the presentation, we will revisit the composition of the base material, where I will identify the specific aggregates needed to build a proper permeable unit paving system. We will now watch a video on the fundamentals of permeable unit paving and new technologies.
In the 80s, Europe faced a series of devastating floods. The increase in sealed surfaces, in particular pavements, were found the largest contributors, triggering changes in stormwater management. Langsdorff Licensing saw a need and created 𝐦𝐸𝐸𝐸, the first permeable interlocking concrete paver. The 𝐦𝐸𝐸𝐸 allows rainwater to infiltrate through the pavement and back into the soil. Due to intensifying urbanization, water runoff is increasing and happening faster, causing more severe flooding. 𝐦𝐸𝐸𝐸 permeable interlocking pavements, or in short, PICP, help reduce runoff back to pre-development rates. After Germany, PICP systems were introduced, often mandated, in Switzerland, Austria, the rest of Europe, the UK, and all the way to Australia and Japan. The concept of utilizing permeable pavements became recognized globally. While there was early success in North America, the market here demanded more research. Starting in the mid-90s, Drs. Ray and Miriam Rawlings, Corps of Engineers, Professor Phelan, Northeastern University, Professor Zollinger, Texas A&M, Professor Shackle, University of New South Wales, Professor Hunt, NC State University, Dr. Drake, University of Toronto, and in particular, Professor James, University of Guelph, found that while offering numerous benefits, maintenance of PICPs can present challenges, especially when cleaning is delayed. Lack of cost-effective and practical approaches prevent the widespread adoption of PICP systems in North America. Novel and practical maintenance and operational methods supported by scientifically based proof are needed. 𝐦𝐸𝐸𝐸 was the first generation permeable interlocking concrete paving stone and had a void ratio 8 to 10%. The second generation permeable interlocking concrete paving stones have a void ratio 6 to 8%. However, clogging and maintenance are now the key concern. The drainage joints have now narrow walls, top to bottom, and over time, the top 1 inch gets obstructed with fine sediment. The Courtright Center permeable pavement test demonstrated that most cleaning methods show limited effect or are time-consuming and expensive. Our new product idea was to address this by changing the paving stone and its joint design. Our next generation pavers and joints are now formed so they can be easily cleaned. Please follow the link to see the simple yet effective solution to the maintenance problem.
Section 2. Case Study. Guaranteed Rate Field. Construction of the Guaranteed Rate Field parking lot was very expensive due to the required stormwater infrastructure. Alternatives to standard stormwater construction practices were being assessed, and 2 designs were developed, one using a standard stormwater infrastructure and one using permeable pavement. The cost of traditional stormwater infrastructure was $300,000, which did not include the surface pavement treatment. The permeable unit paving option combined both the underground infrastructure and surface paving system into one cohesive system with a lower cost. Additionally, the permeable paving system infiltrated all water on site, opposed to draining the water to a municipal system like traditional underground infrastructure. Storage capacity is an important feature of permeable unit paving, and storage should be designed to accommodate an extreme rain event. For Guaranteed Rate Field, an additional 50,567 cubic feet of storage capacity was designed into the system to accommodate a larger rain event. The capacity is related to the depth of the subbase material, which in this situation was 14 inches of base aggregate with 40% void space, supplying 123,667 cubic feet of storage. For typical events, only 73,100 cubic feet of storage is used, but the system is made to accommodate an inevitable larger rain event. The existing soil conditions on site allowed for up to 14 inches per hour of infiltration, so the parking lot did not need to be connected to the municipal stormwater services. Site soils are an important part of success of a permeable pavement, so geotechnical engineers should be involved with the design of permeable unit paving systems. By implementing a permeable unit paving system, no extra infrastructure in the form of 44 inlets, over 3,000 linear feet of pipe, and a storage tank was necessary. Also, by exchanging a traditional stormwater system with a permeable unit paving system, there is an approximate savings of $2 million in underground infrastructure. The resulting permeable unit paving installation had no inlets, no concrete pipe, or storage tank, which led to an approximate cost savings of 15% versus traditional rainwater mitigation methods. The installed permeable unit pavers were 2 repeating bands of granite blend and dark charcoal colored Eco-Optilock pavers. The pavers were installed using machine for ease of installation, accuracy, and speed. In this instance, the installed pavers were treated with our classic finish, but we offer a variety of quality finishes, colors, and shapes beyond what was installed on this project. Eco-Optilock has the highest mechanical installation rates of any interlocking permeable paver. The patented L-shaped design makes the paver clusters easy to install quickly and accurately. Installation rates of up to 12,000 square feet per machine per day have been documented. This makes Eco-Optilock a very competitive permeable pavement that can be installed in even adverse weather conditions. Eco-Priora and Eco-Line are also available for mechanical installation. Section 3, Case Study, Buckingham Fountain. Buckingham Fountain was completed in 2009 and was paved with our Eco-Priora permeable paver with a series finish. The significance of this project is the desire to maintain the appearance of the existing pavement material, but it was failing and needed to be replaced. There was also a need for permeable pavers to improve the drainage on site. We were able to apply our series finish to our permeable unit pavers to closely match the existing color and overall appearance of the plaza space. The same natural stone material that was used to create the original pavement was applied to the face of our pavers in the form of an aggregate, which we refer to as series. The site receives constant foot traffic and is often used for filling, but it maintains its look and feel. Buckingham Fountain is the largest permeable unit paving plaza in the US, and it gave rise to a series finish that has now been used on a variety of projects since.
That's great. We'll take a quick question break. Thanks, Alex, for that video. That was very informative. So we do have a question that was posted. What can be done to lower the material and installation costs of permeable pavers? In Southeast Michigan, we typically look at a cost of $24 per square foot, which includes, let me see if I get this right, which includes a 24 stone base. We have a lot of clays. It's hard to be green when it costs so much. Great question, and that's a constant question and concern that we get, Alex. How can you touch on that?
That is a great question, and it always comes up. I mean, site soils are definitely an important part of the system. So when you're dealing with clays and other soils that don't infiltrate, your costs do go up. That being said, there's a number of ways. I mean, you can always look at product types. So it depends what you're budgeting for products. If you have something like our classic finish versus our Endura versus our Real or Elegance finish, so the material costs are going to be variable depending on that. So that's one avenue to manage your costs. You also have to keep in mind that there's a cost associated with underground infrastructure. So although there might be a higher cost dealing with these clays, you still have the cost of putting in your concrete pipe and your storage tanks and all these other parts of it. Overall, you obviously need to evaluate each project based on the concerns and needs.
Perfect. No, that's great. A common question that I get asked all the time, and I'm sure you do as well, Alex, and Michael in the US, are permeable pavers more expensive than regular pavers?
So yeah, that's another great question. No, they don't need to be. So I think it goes back to my previous question in some sense that we have a large range of finishes and colors and textures. So you can find a permeable paver to fit your budget typically. As far as material costs go, obviously the excavation and other things are independent of that.
Perfect. So we do have another question, Alex, in the posted here. It was mentioned that under the permeable pavers, there's space for infiltration. Is there vehicular traffic over the permeable pavers, i.e., let me see here, when I scroll, it gets rid of the question, i.e., unclean runoff? Can this runoff be infiltrated without any pre-treatment?
So that's highly dependent on your site. One thing that we found, and I presented later in the presentation, is that the jointing layer of aggregate typically captures some contaminants. So it will work in mitigating, obviously not stopping everything. Things like salt in the environment do go through, but oil from cars and things like that definitely can somewhat be mitigated through the joint material. And then the natural soils will infiltrate. Keep in mind that if this was a typical stormwater infrastructure, it would flow downward into your waterways regardless. So having some sort of filtration system through the joints, it is beneficial.
Perfect. And we'll run through one more question that was posted here. Does the permeability come through the joints between the pavers or the paver itself?
So at Unilock, we always drain through the joints. There are some other manufacturers that may drain through the actual unit. The reason we don't do that is if you do have a clog, I suspect it could clog the actual unit instead of the jointing material. So it's much easier to place jointing material than it is the actual concrete paver.
Perfect, perfect. Okay, I think we'll hold some of the other questions to the next break. How's that sound?
Yeah, it sounds good. I think we need to carry on here, so happy to answer them then.
Perfect, thanks.
Section 4, Manufacturing Standards, Reviewing ASTM Standards. ASTM standards require our pavers to have an average of 8,000 pounds per square inch of compressive strength, with a minimum of 7,200 pounds per square inch. The standards also require that our pavers maintain an absorption average of 5% with a maximum allowable amount of 7%. Height tolerances cannot deviate by more or less than 3 millimeters of the intended height in order to comply with the ASTM standard. At Unilock, quality is paramount, so we hold ourselves to an even greater standard than the ASTM requires. Additionally, our absorption average is 4% versus the prescribed minimum 5%, and our absorption maximum is 5% opposed to the minimum tolerance of 7%. These higher standards are significant as compressive strength is important during heavy loading and reducing the amount of water wicked or absorbed by the unit paver to prevent frost shattering. Section 5, Benefits, Infiltration and Pollutants. This diagram illustrates the movement of water through a typical permeable paving unit system. As contaminated water moves through the system, contaminants remain within the first 2 inches of the paving system and are removed by microorganisms. The water exiting the system is higher in quality, which is beneficial to humans and the ecosystem. This chart from the Interlocking Concrete Paving Institute, ICPI, design manual displays the increase in water quality as a result of permeable paving practices. Permeable paving fares well with most contaminants, but does fall short with de-icing chemicals that are commonly found in road salt. These de-icing chemicals make their way through the system due to their fine size. Overall, permeable unit paving systems do well at removing suspended solids and phosphorus, which can cause eutrophication when leaching into natural water sources. Eutrophication is common in agricultural areas where it creates dead zones and can be responsible for algae blooms. Section 6, Design, Materials and Laying Patterns. Before selecting a type of permeable unit paving, it is important to determine what you are trying to achieve. Consider what the goals of the project are. Does the site receive vehicular traffic, or is it a streetscape where wayfinding is important? Are there environmental factors that need to be taken into consideration? Is downstream erosion an issue, and what type of rain events will the pavement need to be designed to accommodate? What local regulatory requirements exist? For example, the Toronto Green Standard requires a solar reflective index of 29 or greater. Determine the site soils, as they will influence the base depth of the permeable unit paving system, and if water needs to be redirected to areas with higher infiltration rates. Lastly, what is the budget for the project? This can determine what type of finishes are available to you and whether immediate costs outweigh life cycle costs. Loading conditions are very important when designing a pavement, and the vast majority of the time they can be accommodated if considered during the design phase, ideally during detailed design. When the pavement receives a load, the base and sub-base components of the unit paving system carry the majority of the load. They must maintain strength in the presence of water for pavement stability. Aspect ratio is a relationship between the thickness of the unit paver versus its longest side. For example, our promenade plank paver is 100 by 300 by 100, having a thickness of 100 millimeters and a length of 300. It conforms to a 3:1 aspect ratio. As a general rule, for heavy vehicular loading, a 3:1 aspect ratio should be maintained. For light vehicular loading, a 4:1 aspect ratio should be adhered to. and all other paving sizes are considered pedestrian only. Laying pattern is equally important to aspect ratio. When designing a permeable unit paving system, it is important to implement a herringbone or double herringbone pattern for areas that will receive heavy vehicular traffic. Other specialized pavers such as Eco-Optilock and Bronte Street paver are also acceptable due to their specific lockup features, but when in doubt, consult your local territory manager. These images illustrate the different sizes of various aggregates used in the construction of permeable unit paving. Take notice of the fact that these materials are all wash stone, free of fines. These tables speak to the different types of aggregates used to build a permeable unit paving system. Careful selection of base materials ensures that an installation can handle almost any amount of rainfall. Installing a permeable paver system above porous soils allows for rainfall infiltration, reducing runoff and flooding. Most soils, even clay, allow for some infiltration. Soils with high porosity, such as sand, can have a higher infiltration rate than the actual rate of rainfall. For example, if it is raining at a rate of 2 inches 51 millimeters per hour and the soil has an infiltration rate of 4.5, 114 millimeters per hour, the soil will absorb water before it can run off. Even poor soil with a low infiltration rate will work. For example, a soil with 0.25 inches or 6 millimeters per hour of infiltration will have complete infiltration after 4 hours of rainfall. Permeable paving is not a typical segmental pavement. Unilock recommends that a professional engineer design a site-specific plan based on available site information. Along with information provided in this presentation, Unilock offers all the data on our pavers necessary for a successful design and implementation of a permeable unit paving system. Section 7. Maintenance, Inspection, and Practices. Before providing maintenance on permeable paver systems, proper installation and protection during construction is required. The following are some things to keep in mind during construction. Verify the correct materials are installed. Hire contractors with experience installing permeable pavers. Review and approve all subbase, base, and joint aggregate materials, and do not allow installation of dense graded aggregates. Prevent construction damage. Restrict vehicles with muddy tires from driving over newly paved surfaces. Do not mix aggregate materials. Refill joint material. Once between 3 and 6 months after installation, repeat as needed, approximately every 5 to 10 years. Lastly, avoid stockpiling of materials on or near the permeable pavements, such as topsoil and mulch. There are several warning signs and visual clues of common maintenance issues that must be prevented and addressed or remediated to ensure continued surface infiltration. These common problems can often be easily remedied by maintaining the proper joint aggregate level. Slow draining or runoff. This is easily spotted during a rainstorm as the surface should drain immediately. Ponding. If there is more than 22 millimeters of water after 1 minute of rainfall, maintenance is required. Surface crusting. Look for deposits of sediment and increase cleaning frequency. Weeds. Plant will not germinate unless there is a collection of soil or moisture, so ensure the joints remain open and free draining. Here is a list of some preventative and restorative methods. Regular surface cleaning significantly reduces the chance of a system clogging, which means other more intensive treatments will likely not be required. This type of cleaning would be considered preventative, but in the event regular maintenance has not been taken, restorative measures can be taken. These include power washing or lifting the pavers to remove their jointing aggregate. For more information on maintenance related to clogging prevention and removal, Unilock has a permeable unit paving maintenance guide. Use sodium chloride for temperature as low as 20 degrees Fahrenheit or -7 degrees Celsius. Calcium chloride should only be used when necessary when temperatures are below 20 degrees Fahrenheit or -7 degrees Celsius. Follow the directions listed on the de-icing product bag, but do use them sparingly. Only apply the minimum amount necessary to melt the snow and ice. Over-applying the product can result in damage to the unit pavers. Sweep and remove any excess de-icing chemical after the ice and snow melts. After the winter season, thoroughly wash the surface of the pavement to remove any remaining excess de-icing chemicals. When using plowing equipment, it is important that they are equipped with plow scrapers and blades made of high-density plastic to reduce the risk of damaging paver joints and the surface of the pavement. While scraping the surface without this protection will not compromise the structural integrity of Unilock pavers, it may affect the aesthetic of the surface by leaving behind rust marks and further damaging the finish. In contrast, a rotational snow broom can be used to remove snow safely from the paver surface. Unilock suggests establishing a best practice maintenance program to ensure longevity of the system before restorative action is required. I will briefly take you through a maintenance program. After the snow melts, March 1st to April 15th, begin using a broom, blowing equipment, or a rotary brush to clean the surface of the unit paving. Give special attention to areas used to stockpile snow. Once this is complete, replenish the joint aggregate. Every 5th year, vacuum or power wash problem areas and refill the joint material. Late spring, April 1st to May 15th. Again, use a broom, blowing equipment, or a rotary brush to remove organic material from trees and shrubs. Collect any additional debris, especially from areas that have been mulched or planted with annual flowers. Replenish the jointing aggregate material as necessary. Late fall, October 15th to November 30th, once again, clean the pavement using the same methods and replenish the joint aggregate material as necessary. Make note that various factors will affect each project's preventative maintenance timeline, so they must be individually reviewed. I will now play you a short video on Duraflow with Rapid Clean technology as it relates to maintenance.
Permeable interlocking concrete pavements with Rapid Clean technology Part 2. Previous research and 20 years experience taught us that the current generation of permeable interlocking concrete pavers can have some maintenance issues. See our Part 1. Were not cleaned regularly and diligently, over time, the infiltration rate of a permeable pavement diminishes significantly. Most standard cleaning methods show limited effect. Reason lies in the design of the current generation of PICPs. To quote Jennifer Drake, a researcher from the University of Toronto, the lack of proven cost-effective and practical approaches for permeability restoration prevents the widespread adoption of PICP systems in North America. Novel and practical maintenance and operational methods supported by scientifically based proof of effectiveness are needed. Rather than enforcing unrealistically strict maintenance schedules and expensive special equipment to maintain current PICPs, we developed a new system by redesigning the paving stone shape and joints, specifically with maintenance in mind. The key performance objectives during the development of our Rapid Clean technology were intended for all traffic loads, offer infiltration rates of at least 10 inches per hour equal to the original 𝐦𝐸𝐈 stone, be fully ADA compliant, less than half-inch joint width, successfully pass most rigorous cleaning trials. Here are the schematics of the design approach. Take typical concrete paving stone, here in top and side view, and incorporate channels or conduits along the sides. Create special concave openings along the top of the paving stone, called cupules. Here is one of them. Fill the conduit and cupule with drainage aggregate. Now pressurized air or water would be able to rapidly dislodge sediment and debris and facilitate easy cleaning of these cupules. Also, brushes and bristles can now dislodge debris rapidly. So what is a cupule? Cupules are concave natural or man-made depressions on the surface of rock or stone. A test rig was constructed and set up at the University of Guelph laboratory to model the vacuum head of a typical regenerative air street sweeper. So much for the theory, now the test trials. We tested many different cupule designs to find the best performing one. As seen, they would vary in depth, width, angle, and contour. For the final version, the cupules are formed to fully comply to ADA guidelines, having a maximum gap less than half-inch wide. On first glance, this CAD drawing may look complicated. The rendering on the right better shows the final pavement. Here you see the production of the first pavers. Field testing commenced in Ayr, Ontario, November 2016, utilizing a 20 by 40 foot section of an existing permeable parking lot. To set a benchmark, the initial infiltration rate of the existing permeable pavement, the existing bedding layer, ASTM number 8, and existing granular A base were tested using the ASTM C1781 infiltration test. Then the new Rapid Clean pavers were installed. Next, the cupules and joints were filled with drainage aggregates in various gradations. Here, a close-up of empty and filled cupules and joints. Now the full-scale cleaning test started using a large regenerative air sweeper, a mid-size rotating brush sweeper, a small walk-behind power brush, and a portable handheld blower. Visible here is the removal of sediment from within the cupules. Further infiltration tests after 3, 6, 9, 18, 24 months were conducted. These tests demonstrated that after each cleaning, even when only using just medium and small motorized brushes, the infiltration rates could rapidly be regenerated to the initial levels of between 100 inches per hour and 500 inches per hour. Of note is the industry recommended long-term infiltration rate is to be above 10 inches per hour. Test results were published in several peer-reviewed research reports, journals, and on Stormwater Conference. Links can be found on our website. In summary, findings showed that this new permeable interlocking concrete pavement can maintain or restore the infiltration rate rapidly using readily available maintenance equipment, even simple handheld tools. The cleaning speed goes up and the maintenance cost goes down. Moreover, cleaning intervals could be extended as cleaning becomes simpler, even when clogged. While all PICPs are intrinsically beneficial, this new rapid clean permeable pavement system gives added confidence that even neglected or delayed, maintenance can now be performed easily when required or mandated. Besides the acknowledged benefits of PICPs, such as better aesthetics, high traffic loading, easy access of underground utilities, low life cycle cost, these major savings in maintenance costs for municipalities and facility owners will provide new opportunities for the use of permeable interlocking concrete pavements. For additional information and availability, contact www.uni-groupusa.org.
Perfect. We'll take a quick question break. How's that sound, Alex?
Sounds great.
Perfect. So there is a few questions here. So one of the questions, some cities have introduced a stormwater tax based on the amount of paved surface. Does the use of permeable pavers allow you to avoid that tax?
Yeah, I can't speak specifically about that because I don't know the rules and regulations for every municipality. I would assume some. But I mean, if you want to contact me afterwards, I'm sure we can look into it together.
Perfect, perfect. And another question that commonly comes up that I get, and it's pretty basic, but it's always great to speak on it. Should a geotextile layer be added between the base layers?
So I refer back to the detail that you saw, that the only geotextile that's going to go in a permeable system is between the native soil and the infill aggregates as per that detail.
Perfect, perfect. Okay. I think we can move on. Some of the questions that were submitted are more so comments of local installation practices and ICPI requirements that were answered by our guest speaker, Jennifer Drake. So that's awesome. We'll continue on. How's that sound?
It's perfect. Thanks, Danny.
Section 8. Products, finishes, sizes, and colors. Our classic finish is tried and true. It is frequently used as an economical option due to its durability and familiarity as it has been on the market for some time. Our classic finish is made with through-mixed concrete that contains larger aggregates for durability, which can also be seen on the surface of the unit paver. Enduracolor utilizes the same durable concrete as a classic finish, but is then topped with a face mix to provide a range of textures, colors, and lasting color. The top of the paver also has a finer finish, so larger pieces of aggregate are not visible. Our Elegance line is made using wet cast concrete, whereas other products use a dry casting method. By wet casting the pavers, we are able to offer seamless textures and colors, as well as form finer features into the pavers. Additionally, our wet cast concrete unit pavers have a higher compressive strength to form an even longer lasting pavement. Our Eco Optilock has been used for years due to its durability and adaptability to any situation. It's made with our classic dry casting manufacturing method and is formed in an L shape for increased lockup. Because of these characteristics, it is economical and can withstand heavy vehicular loading without movement or cracking. Duraflow is a permeable pavement specially designed with rapid clean technology. Cleaning in the correct direction allows for easy extraction and replacement of jointing aggregate. Smooth is new and provides designers with a permeable paver option that can be installed in a random pattern. It also has a smooth, modern aesthetic. With the success of our Promenade plank paver line, we introduced Eco Promenade to supply the design community with a plank-style permeable option. This product is available in a face mix and can be used in heavy vehicular situations. Our Tribeca cobble paver provides you with a unique cobblestone appearance in our durable and exclusive series finish, while also being permeable. LEED, Leadership in Energy and Environmental Design, is a green building certification program that recognizes built-in-class building strategies and practices that have a positive impact on the health of occupants while promoting renewable clean energy. To receive LEED certification, building projects satisfy prerequisites and earn points to achieve different levels of certification. Unilock products can help with their certification goals. DriveCell is a reinforced soil structure product that enhances the performance of pavement structures. I will now play a short video from Iowa to further explain how it functions.
The addition of DriveCell within pavement structures maximizes the strength, stiffness, and resilience. To help understand this, we will discuss how pavements fail, how DriveCell works to prevent failures, why this is important, where we can use DriveCell, and the benefits that DriveCell provides. Pavement structures are strong in compression but weak in tension. They can fail in different locations, from different causes and mechanisms, but ultimately they fail in tension. DriveCell stiff geocells strengthen pavement structures by combining the best of both worlds from geogrids and flexible geocells by reinforcing and confining. This results in the maximum strength, stiffness, and most importantly, resilience for flexible pavement structures. DriveCell can be used in the base layer on decent subgrades and directly on weaker subgrades like a snowshoe to reduce the pressure on the subgrade. DriveCell can be added into conventional unreinforced pavement structures to significantly increase their strength and performance. Or you can take advantage of the strength increase by reducing the thickness to reduce the excavation and granulars while maintaining a similar or greater strength when compared to the original unreinforced section. Here is a comparison of the wheel load distribution for a flexible versus rigid pavement. In a flexible pavement, DriveCell maximizes the stiffness to increase the load distribution and maximizes the resilience to increase the durability. Together, these maximize the performance lifespan. Ultimately, this reduces the maintenance costs and minimizes the life cycle costs. For permeable pavement structures, the base and subbase are typically composed of open graded granulars. The design priorities are structural first and then drainage. A rigid and impermeable concrete base layer is a mistake under a flexible and permeable concrete paver's driving surface. The concrete should be replaced with DriveCell. As shown on the very right, 2 layers of DriveCell can be used in pavement structures, one on the base and one on the subgrade to further increase the reinforced strength and minimize the excavation and granulars. The original concrete base for this driveway was replaced with DriveCell. DriveCell can be used on the roofs of parking garages to improve performance, especially at transitions, and to reduce the weight of the granulars. Tension cracks typically form at transitions from one type of pavement to another. Installing 2 layers of DriveCell along the transition helps smooth the transition and prevent cracking. Too often, pavements and curbs break up around catch basins. Installing DriveCell helps tie this area together to reduce costly repairs. Pavement structures often deform and crack over culverts. Installing DriveCell under the culvert helps spread the load and reduce the excavation required. Installing another layer above the culvert in the pavement structure helps prevent deformation and cracking. DriveCell maximizes the long-term performance of pavement structures for maximum benefits. During construction, the excavation and granulars can be reduced. Plus, the installation is quicker and easier. This results in overall time and cost savings. Maximizing the resiliency maximizes the durability. This means more wheel passes, less maintenance, and smooth transitions. Finally, using 𝐦𝐸 has direct and indirect environmental benefits, including reducing export and imported materials, reducing truck traffic and related air and noise pollution, all while reducing the overall carbon footprint. Thank you very much.
That concludes today's pre-recorded presentation on permeable unit paving.
Perfect. Thanks, Alex. That was great content. Judging by the amount of questions, very hot topic. Permeable paving is always for us. So we're going to take some of these questions and hold them till the conclusion of our presentation. That way we can try to answer as many as possible. Well, thank you for that. On to our next segment. Jennifer Drake is an associate professor in the Department of Civil and Mineral Engineering. Her research group works to develop and improve blue, green, gray stormwater infrastructure to mitigate and minimize urban flooding, helping our cities become more resilient and adaptive to a changing climate. With that said, I'll pass it over to Jennifer. Thank you, Jennifer. Take it away.
Thanks, Danny. Okay, well, welcome everybody. I'm going to be speaking in the last 15 minutes about maintenance for permeable pavements and some of the work that my research group has done in the past few years. Bear with me. Okay, so I think as you know, the reason I love doing these types of lunch and learns and education seminars is because LID broadly, of which permeable pavement is one, you know, still suffers from low uptake from all stages, you know, from developers and clients asking for it, or municipalities accepting these types of technologies. And from what I've observed over my career is that this hesitance about using permeable paving and other LIDs comes from a number of sources. One is the experience of past failures and the fact that all of these technologies are still in their early generations and have changed drastically over the last 2 decades. And we've seen examples of that just in here about the first and second and third sort of generation of paver designs. Permeable pavements and permeable pavers have changed drastically in terms of their designs. And so their performance has actually changed very significantly. And so they are much more cost effective and longer lasting than they were previously. Other issues in terms with this hesitance about how can we ensure private ownership, that they are going to be operated and maintained. And then when it comes to executing the maintenance itself, generally lack of experience or access to equipment or systemized practices, it continues to be a barrier. As we've already seen too, cost is certainly a driving consideration, and recognizing and balancing the fact that permeable pavements are two things at once. They are stormwater technology, but they're also a pavement system. And balancing that, you know, a permeable paver may have a higher price ticket, but it's providing two functions. And so trying to figure out how we square that is very difficult. Excuse me. Public misconceptions, especially around winter, continue. And then at the end, just having data, having information about how these systems are going to perform once they're built and in the ground, so that policymakers can update policy or set criteria, is a real need. The photo here, which is, I'll let you take a guess of which section has the permeable pavers. Hint, it's the part that has no melted snow in the foreground of the photo. Okay, so one of the most important functions of permeable pavements is their ability for quantity control. And so I have a very short snippet of a pervious concrete pavement, and because we look at all types of pavements, but just so we can see the real benefit that these products have.
It's really raining now and no flow from hydromedia. a lot of runoff from asphalt.
I love that clip. And so that is really the most significant or most important outcome that we have from when we add permeable paving is it provides near source control of stormwater, preventing not only peak flow, maintaining the water balance, but also preventing pollution that's associated with that stormwater. However, if we want to have that goal, if that's our goal here, we need to make sure that these systems are constructed and operated correctly. And so in this presentation, I'm going to kind of highlight things that, as you know, this being a audience of practitioners, things that we really need to be considered and common mistakes that I do sometimes still come across. So top one is, of course, that permeable interlocking concrete pavements are different from conventional impermeable interlocking pavers. And one of the most notable differences that an installer can sometimes overlook is that the jointing and bedding material is different. Under no circumstances should we ever construct this with sand. We use chipstone, as we saw. That's really just basic construction error. Next is, of course, if we want these products and these pavements to be high performing when the construction is done, we need to make sure we protect that permeability during the construction phases. So erosion and sediment control on the construction site is essential to make sure that we don't preemptively damage or destroy that permeability by contaminating it with construction soils. To do that, site inspections to prevent construction mistakes are the most powerful tool we have. And also, again, this is a common thing, but if that surface is going to be used for sequencing and loading other materials, we want to make sure we protect both either the sub-base layers or the paver surface itself by putting stockpiled material on tarps so that, again, we don't have stuff migrating in and prematurely clogging the systems. When we have a product or a paver that's now in the ground, what we need to do, just like with any other infrastructure, is maintain it. And that starts with just simply inspecting the surface. You know, whether any drainage infrastructure requires maintenance, we clean out our catch basins every year. We clean our streets every year, and we clean our regular parking lots. But when it's a permeable parking lot or permeable pavement, we need to think about things a little bit differently. So things that we should be looking for before a rainfall event, just when we're visiting a site, is looking for items that may be contributing to reducing the permeability. So leaf litter, pine needles, trash, cigarette butts, materials like that can accumulate inside the joints. And then also looking for the formation of sediment crusts. So you can see in the photo here, this is an example of what this looks like. It's when you get a layer of caked sediment in that top inch, in that top surface, that basically prevents the water from getting through and accessing the sediment-free aggregate that is further below. And then, of course, if there are the presence of weeds, those plants only become established when there is sediments in the soil, because it's the sediments that hold the moisture that the roots are going to be able to access. When joints are sediment free, you don't see the same amount of vegetation because it's a very open and actually quite alkaline material environment, so it's not very hospitable for vegetation. During and after a rainstorm, the question is really simple. Do you see any water? If we see water accumulating on the surface of a permeable pavement and persisting, both during and then after the rainstorm event, that is our indication that that section of the pavement or the pavement more broadly requires some maintenance. Another approach we can do is actually to track the performance over time by doing a systematic, repeatable test that measures the infiltration test. And you saw examples of this type of single ring infiltration test in the presentations previously. In these types of tests, we're not replicating a rainfall event, but what we are doing is applying a known volume of water and timing how long it's going to take to infiltrate. And that measurement then can be used over time, you know, if it's repeated once a year, to track the pavement over time and then plan for restorative maintenance or preventative maintenance as is deemed appropriate. So let me share with you some recent research work that we've done at my group. So, you know, I'm very interested in maintenance. And one of the challenges with studying this is that every parking lot or laneway or walkway is unique. And so it becomes very challenging to produce that, you know, scientific sound evidence that I was quoted on about how different technologies are going to restore the surface permeability. So what we've done with partners in this project is we constructed a generic permeable pavement pad and then systematically clogged it. Using street sweeping from the City of Toronto municipal lots, we measured on site specific amounts of material and applied them directly on the joints and wetted them so they wouldn't blow away. And this allowed us to uniformly clog the surface and then directly compare different common cleaning equipments that municipalities or property owners might have available to them when they're looking to restore their surface permeability. So you can see in the photo here, this is the permeable pad prior to clogging, and then you can see what it looks like afterwards. In the photo on the side too, you can actually see the difference in color between the clogged section and then we had an unclogged cell for comparison way at the back there. So we use this pad to then test different types of street sweepers and other cleaning practices that one could look at or might want to use for their permeable pavement. So this included true vacuum sweepers, regenerative air sweepers, waterless mechanical sweepers, power washing followed by manual vacuuming, and then specialized equipment intended for PICP restoration, which was a two-part process of pressurized air followed by vacuum, high suction, high strength vacuuming. So I've got a little snippet of just the So what did we see? What was the findings about this? Well, the good news is that we were able to demonstrate, because this was a controlled setting, you know, the advantages and limitations of these different technologies. And the good news is, of course, all of the tested treatments provided some restoration. This study was limiting in that we only allowed the technologies to provide a single pass over the pavement. They weren't allowed to go more than once. And what we can see is that vacuum sweepers by far provided the vacuum sweepers and the pressurized air vacuum system provided the highest restoration of surface permeability. My goal from this work is to let property owners know that they have options when it comes to maintenance. These different practices are going to be better or less suited for different types of installation. Manual pressure washing is not going to be appropriate on the, you know, that largest PICP installation, but for an individual homeowner, it would be a very feasible and practical one, and it restores the maintenance. We also observed that some of these technologies, we do need to think about the way that we execute the maintenance, especially with sweeper trucks, where they have a vacuum head on just a single spot. And so we need to be mindful that only a portion of the pavement underneath the whole vehicle is actually being treated. And so we need to plan our sweep paths appropriately. So in the photo, or in the side photo here, you can see that, for example, the air sweeper, and the waterless sweeper, you can see how there was higher rates of restoration in some sections. And of course, one of the limiting factors of this site is that we couldn't actually, it was just a straight path. We couldn't move the vehicles over. But so in practice, you would want to do strips that reflect the size of the vacuum head, or multiple paths in a hatched pattern. We also observed, although I don't show it here, that of course the orientation of the joints definitely affects how much water is going to be removed, or how much material is going to be removed. Joints that are in line with the path of the vehicle will have more material removed than those that are perpendicular. So again, cleaning, especially if we're looking at maintenance with sweeper trucks, cleaning with a hatched pattern is going to ensure more uniform coverage, and thus, higher restoration all across the surface. So other considerations that we've looked at, but I don't have time to talk about here, but is of course the impact of clays and silts. As I said, we were testing regular street sweepings as our clogging material. But if you have a site that's exposed to clays or silts, or maybe that's the soils in the general area, maintenance equipment performance will drop significantly. Similarly, others have shown that if you have pavements that are receiving run-on, additional inputs of stormwater, they are receiving higher sediment loads. So again, maintenance will either be more difficult or is going to be required more frequently. Multiple passes on sweepers will result in higher restoration and more uniform restoration of infiltration rates. And lastly, the most important thing is maintain early. The maintenance that I've talked about and presented here is what we would call restorative work, when the pavement's been left and been neglected, and now we're trying to bring it back. This is much more simpler to do if it's rolled into an annual practice of maintenance. And so really, the take-home message I'd like to leave you with today is maintain early and save yourself a lot of effort. This work is, I must acknowledge, has received funding from NSERC and 𝐸CPI, as well as many other partners, and my research students who did. I could never get anything done without them. Jody, Jeff, 𝐸CHIMENE, and Kirti, thank you very much, and I'm happy to answer some few questions.
Perfect. Thanks, Jen. That's awesome. I know you're kind of tight for time. Not sure if you can. I think I just heard that you're okay to answer a couple of questions.
I can answer one or two questions.
Perfect. Okay, so please submit your questions. Jen, I know you had answered one of the questions in the question and answer box, but we'll make it known to everyone in attendance, and then maybe you can touch on that. So one of our attendees, who I'm quite familiar with, had posted this question: our boulevards are required to accommodate occasional heavy loading, such as hydrovac trucks and maintenance vehicles. What type of base material could support this type of loading? Wow.
Yes.
Yeah.
So as I said, I guess I should have posted it more broadly, is that so you can design permeable pavement systems for any type of vehicle loading. The pavers themselves, as concrete pavers, are very strong. And so they're typically not the limiting factor. What we need to ensure is that the loads are transferred appropriately through the base and sub-base. There are some really good guidance documents on how to do that, including just tables in pedestrian only, or pedestrian and occasional heavy use, like emergency vehicle or cleaning vehicle. And you can find those resources. Both 𝐸CPI publishes a design guide, and then there's also the ASCE American Society of Civil Engineers publishes a design guide, and they both have nice summary tables about if you have this many of easels or this traffic loading, what is the appropriate depth given your soil strength underneath.
Perfect, perfect. And another question here, from the perspective of a site development consultant, can we ensure that the correct installation methods are followed and no damage? Hold on here. This scrolling thing is a little bit tedious here. So basically, his question is, the consultant can ensure that it gets installed correctly. What can the owner of the property do post-install to make sure, or to help mitigate any failures?
Yeah, and I think I've sort of outlined what the expectations should be for maintenance. If you're a consultant and you are recommending any LID but a permeable pavement as a product, it should be clearly communicated to the eventual property owner what is expected or what is required in terms of annual maintenance. I think that really that's the most important thing, that in terms of that consultant role, is including that and clearly communicating it. Obviously, you don't have control about what somebody does, what people choose to neglect or not, but you can, give them the best information and outline in real simple to understand how to maintain and what they should be doing and when they should be doing it. I think that's probably the most valuable thing you can do.
Perfect. And as Alex mentioned in his recorded segment as well, I believe he touched on it during a question. Unilock did prepare, with the guidance of all the associations out there, we did prepare a permeable maintenance guide that can be very helpful for the owners. And of course, the information that Jennifer Drake is providing, a lot of that information is in our manual or in our maintenance guide. Do you have time for one more question, Jennifer?
Sure, I'll take one more question.
Perfect. So many public works departments have misconceptions about permeable pavement. How do you change their minds? Wow, that's a loaded one.
Yeah, I think I know public works gets a bad rep, and unfortunately, I think it's a result of the fact that public works has been excluded from the discussion during the planning and design phases of the projects, and in many cases is then left with new infrastructure and insufficient budgets to operate and maintain it. So I think one of the best ways for changing public works departments' conceptions is to engage them early in the design stages, because everything has maintenance. If we don't do this, then we're maintaining our stormwater elsewhere. And what we need to do is make sure that we have all stakeholders included, so that we're making sure we're using the right technology for the system, and that the resources are being put in place so that it can be maintained. As well, citing local performance research like I do can also be very helpful, because people just inherently are more trusting of stuff that's been done in their community. For whatever reason, we are all convinced that only Ottawa knows what winter is truly like, and only Mississauga knows what winter is really like, and only Vaughan really knows how dirty things are. So when there is that available, and that's one of the reasons why our group focuses so much on trying to do research here in Ontario, it's very, very helpful in terms of changing minds and helping people actually either say, okay, let's give this a shot, let's try this one, or opening their minds to trying something new if it's new. Yeah.
Perfect. No, that's awesome. We appreciate your time. Again, Jennifer's contact information is here on the screen. Feel free to reach out to her, especially twice on Sundays, right?
I'll mention too, if anyone's interested in copies of the peer-reviewed papers, because a lot of this work has been published. I'm more than happy to share that as well. All of our studies are done here in Ontario, so if you're in the Ontario area or cold climate area, you might find that helpful when you're trying to get a property owner to go with permeable pavement for the first time. All right.
Perfect. Thanks, Jennifer. Appreciate it. So we will continue on here. So I just want to quickly mention, again, thank you, all the attendees, for your time. Thank you, Alex, for your portions. That was great. And the answers to the live questions, that was very informative. Again, I do want to mention, as a reminder, we're running these seminars throughout the month of February into April. Tomorrow, our presentation or our seminar is on successful streetscapes. I will be the one of the presenters. We will have a live presenter as well, and it's going to be hosted by my colleague, David Robbins. Next week, we are following up with a seminar on roof decks. That is February 9th at 1 p.m. And the following that, next Thursday, will be on engineered retaining walls with Reese Stone as our guest speaker. So again, please log on, register. We want to see all these questions. We want to hear from you. Of course, we want you to consider using Unilock products. Again, thank you for your time. We will be I will post a link now to the link for our survey. You will be receiving this link. You will be receiving this survey via email. Again, if you are needing the Con Ed credits, feel free to reach out to us. We will be getting an email link, and we can provide you that letter. Thanks again on behalf of Unilock. I'm Danny Gatto and Alex Bartolo. We both thank you, and we'll see you tomorrow.